Okay, hello everyone. Welcome for everyone who working for new energy industry today. I'm Lisa, and I'm going to represent my company, Astronergy, to give this speech. Okay? Astronergy is a subsidiary wholly owned by Chin Group. I think most of you may heard about the Chin Group. Chin Group, as a 30-year-old listed company, covers the entire industrial chain of the power industry, from the power equipment to the investment and also the development business. But here in Malaysia, Chin is mainly as a supplier to offer power equipment. As a main branch of Chin, Astronergy focuses on the solar module part, from the upstream silicon wafer to the downstream cells and the modules. We, as an independent module brand, to take part in the whole overseas market. All Astronergy do is to deliver the best solar panels to this project. So in this section, let's focus on the most important equipment in solar project, the solar modules. How solar modules will develop in the following years, and let's just look through the industry chain. First of all, I would like to ask a very easy question to everyone. What is the true need of market for solar modules? So actually the past decades have seen the installation demand is actually increasing, but the installation area is decreasing. Meanwhile, generally the equipment costs are getting lower, though it may fluctuate in a short term, but the logistics and the labor costs are getting higher. So, we not only want more watts for each square meter, but we also want to generate more kilowatts per watt. This is not enough. We not only want it to generate more, but also we want the degradation is slow. I will just give you an example. Like the man always want a lady to keep beautiful and getting old slowly. So we can see the whole market is just like, for the P-type cells is actually facing its maximized efficiency now. So to produce the higher power solar modules, we are using bigger sized wafer and a bigger sized cell. So let's see in these slides, we can see that the M10 sized wafer is growing more and more, and also the 210 wafer that is also growing more and more. I mean the M10 wafer is actually equals like 545 watts modules, and that the 210 wafer equals to the solar modules over 600 watts. Okay, so this is how wafer goes in recent years. Also, to maximize the energy generation, we use more bifacial, that is double glass modules, that is become very popular since this year. And another reason for this is we just want to adjust to the complicated scenario. Especially we can see the floating projects become very active these years. I also heard that we have several floating systems in LSS4. But either wafer or modules, the size is always limited. The size of P-type, like over 600 watt module, is already bigger. You can imagine that this kind of module is bigger than a door. Even hard for two men to install. We cannot ask factories to manufacture the modules as big as this screen in the future. So how should we go in the next step? The key is to improve the efficiency of the cell or the solar modules. That is to make the technical revolution. Compared with the P-type cell, the efficiency is only up to 24.5%. But the N-type cell can reach to 29%. We can see in these slides here here we can see the green HJT top cone, they all belongs to the N-type cells. So we can see the N-type cells, they grows more and more in the future, but the monoPERC, they are getting very less in the future. So all the data is collected under PV-Link info. So this is why you can see, according to these reports, the N-type cell accounts very outstanding proportion, and the proportion of N-type cell remains increasing in a very high speed. So, based on the reasonable prediction of the market trend, in order to adapt to the market development trend, Astronergy focused on the improvement of technical route. We lay out a large number of N-type production lines. The layout of N-type modules, we can see, increases year by year, and the overall capacity of next year is 38 gigawatt, and the N-type will account over 50%. In these slides, we can see the white lines that represents the whole industry N-type cells, how N-type cells grows. Okay, so why the module industry start pay more attention to these N-type cells, to the N-type modules or N-type cells, or why we think N-type modules will become the mainstream product in the very near future? So I want to, let's understand this through a case. This is a real case, happens in 2021. Chin has invested and developed a 19.6 megawatt solar block in Australia, Brisbane. By the way, the annual temperature of Brisbane is over 26 degrees, and the summer is over 30 degrees. It's rainy and wet in the summer, so the climate is just like Malaysia here, right? The whole project is under 19.6 megawatt, using one portrait horizontal single-axis tracker system, using bifacial modules, 20% for ground albedo, 1.18 DC-AC ratio, and 1,500 volt for system voltage. We just compare the modules between PERC 550 watt and with the top cone, which is N-type bifacial modules, that is 565 watt. I give you the data for two different modules to compare. In this slides, we can see, although we are using the same cell quantities, the size, the weight, but the N-type modules have more advantages than P-type modules. You can see, for the besides the power output is much higher, the temperature coefficient is better, which means the temperature goes higher, the output loss is less than the PERC modules. The bifaciality is higher, the degradation is lower, either in the first year and in the following years. Also, the price is much more expensive, 1 cent higher than the PERC modules per watt. And I'll explain the price later. And after the calculation, and also I mentioned this is a real case happened in Brisbane. So after the calculation and a year and a half running, we found that the energy generation is actually higher. We can see when we use the N-type bifacial modules, the energy generation is 2.96% higher than when we're using the PERC. This is mainly because of the LID, the temperature loss, and also bifacial gain and the annual degradation. They all contribute to the higher energy generation. But the system cost can remain the same or even lower. This is because each piece of module has higher output, so the BOS cost is less. and the O&M cost is less. That is a real cost-effective modules. So obviously, we do concern about what about the LCOE? The generation output is higher, the system cost is lower. So the LCOE is low, that is obviously. But now, let us think in a very different way. Let's assume when the LCOE for these two different modules, they achieve the same. What happens? How much cent can N-type modules higher than P-type modules? So the answer is 4 cents. I mean, the price adder can be 4 cents USD dollars. But we, as a manufacturer of the modules, we still benefit the 4 cents to our customers. Okay, so that is a real case to lead you to learn more about the N-type modules works in real cases. So in this section, let's think about once again how N-type make these things all come true. Because all the efficiency data or the temperature coefficient or the degradation, they are all tested under a laboratory. But actually, we use them in a real environment. So in the real environment, the weather can be extremely hot, wet, cloudy, less sunshine, or just water. This is how N-type surprised us. In other words, this is besides the power output why we choose N-type. First of all, N-type modules can cope well with the extreme weather, cold or hot. It's better than P-type, especially in the hot weather. Okay. Secondly, the N-type modules, they can absorb the sun rays better, so it behaves perfectly in the wet and cloudy weather. And thirdly, when we're using double glass modules in some certain area like the grassland or on a lake or somewhere that can reflect the sun rays, it can have better airs. Don't even mention about the warranty letters. We give 30 years warranty letters for all N-type modules. So this is the degradation you can see very clearly from this slide. In the green part, the first year the degradation is less than 1%, and the annual degradation is less than 0.4%. Okay, so we recommend all of our customers when you are gonna use it on a rooftop, we recommend these 3 N-type modules for the rooftop. That is 415 watts, 475 watts, and 565 watts. But when you are gonna use in the utility scale, we recommend that 565 watt modules and the 625 watt modules. Okay, in the next time, let's just look through the roadmap of Astronergy in the past few years and what we are doing for this year. We also produce the P-type modules. We're also doing the P-type modules, but since this year, we pay more attention to the N-type modules, and in next year, the production of N-type modules is over 50% in our production lines. Yeah, for all the module factories, the main technology, the core technology for module factory is how to make high efficient cells. So Change also has the cell factories. So this is our main technology for making cells, and the high efficiency cells can be made to high efficient modules. And once again, these are the main features or the main advantages of our N-type modules. We have high power and efficiency, high energy yield, high reliability, and aesthetical appearance. Okay, I'll give you some data from all tested under the TUV lab, so you can know more about our modules. For the N-type modules, we can see from the TUV test, the LID and TID are both lower than the P-type modules, PERC module. And under the test, we find like that we have a better temperature coefficient. So the temperature coefficient is very important here in Malaysia because when the temperature goes higher, the efficiency of the solar modules will go down. So we must have a very better temperature coefficient to use here in Malaysia very hot weather. So this is the high bifaciality, so we can use it into more complicated scenario like the grassland or on the floating system. Okay, this is the certificate and awards from the different platform, and yeah. Okay, next one. We also keep. For the past 7 years, we are always the Bloomberg Tier 1 solar modules brand. Okay, till now, our factories have already have 20 gigawatts solar modules capacity, and we have 6 gigawatts N-type solar modules capacity. Okay, so thank you for attending today's today's meeting, and thank you for everyone.